And so we've just seen a discussion on length. Length is a one-dimensional unit of measure, just measured in a line, basically. So now what we're going to do is we're going to look at expanding that into 2 dimensions and then 3 dimensions. The two-dimensional equivalent is called area, and the 3-dimensional is called volume. We're going to kind of take a look at those together here. But what we really need to do is to make our units well defined. Okay, so I'm going to give you a little example here that's going to help us, excuse me, to identify the units of measure that we're going to use for area and volume. We'll start with area. So just to kind of move this along, if you think about a rectangle for a moment. Draw that a little nicer. There we go. Take a rectangle, and I'll just make a real basic example here. Let's take a rectangle that has 3 inches, a 3-inch long side, and maybe a 5-inch long side here. See if I can cut this somewhat evenly into fifths. There. Okay, so 3 and 5. Okay. Now these are actually longer than 3 and 5 inches, but I've got to give you something to work with that you can see on the screen there. So 3 inches and 5 inches. And so the length, linear length, is a measurement of the edge, okay? But what I really want to do is figure out how much space is contained on the inside. The area, just as a general definition, area is the amount of space on the inside of a 2-dimensional object. 2-dimensional object is something like a rectangle, a triangle, a circle, a shape like that, a polygon. And it doesn't have to be a real nice polygon like a rectangle or triangle. It could be a star, a heart, any object at all. It could be a driveway. It could be a property line, right, or the edge of a property. Actually, the edge would not be the area, the inside of the property. And lots of different things like that. So any 2-dimensional, it's probably supposed to have a hyphen there, 2-dimensional object, okay? The amount of space on the inside. And obviously things like this rectangle here has less space in the inside than the entire whiteboard that I'm looking at, right? So there's got to be a way to measure the difference between those, and there is. But we have to define our units. And so if I know the linear length of the edges, the length, okay, then what I can do is I can use that to split up the object into what we call square inches. And we know that squares are basically rectangles, 4-sided figures that have all equal sides. Quadrilaterals, I guess, technically. Assuming these are all perfectly parallel. What I've done is I've taken and converted the 3 inches to 3 rows of, I don't know, little boxes, little squares, and the 5 inches into 5 columns. And each little box here is a 1-by-1 square, okay? So this right here is 1 inch by 1 inch, or we say 1x1 or 1-by-1, okay? A 1 inch by 1 inch square, squares have equal sides on all 4 sides, is called 1 square inch. Okay, 1 square inch. And 1 square inch is a unit of measure when we're dealing with things where inches is reasonable, or inches are reasonable, I should say. 1 square foot, if this was 3 feet by 5 feet, we would be looking at square feet as our unit of measure, okay? And a square foot is just basically a tile that is 1 by 1. If you're on a lot of times, even at Delta in our classrooms, we have little tiles on the floor. They're laminate, vinyl, I don't know what they are exactly. But they're typically about 1 foot by 1 foot, 1 square foot, okay? Maybe they're more like 11 inches by 11 inches, but they're close to 1 square foot anyway. And so the area measurement, this is going to be actually our unit. So a unit is 1 square something. It's either a square inch, a square foot, a square meter, a square kilometer. That's typically going to be a nice unit of measure to use. And so the area then is calculated, or is not calculated maybe, well, it can be calculated, but the area is the number of these square inches that make up the object, okay? So it's the number of square inches, or whatever that is, whatever that unit is that we're using, that the object contains. Now sometimes it'll contain a portion of a square inch, right? You don't have to get the whole tile in there. You can have pieces of tiles, or if you have odd shapes like circles, you can't fit, it doesn't fit perfectly these tiles because of the rounded edge to it. So you have to put some decimals in there, right? Portions of tiles to fill in. But anyway, it's the number of tiles that it contains. So that's our, or square inches, right? Square feet, whatever the tile size is. And so that is how we define our units of measure for area. Now it's just nice to do this with a rectangle because it's easily calculable by, calculatable? Not sure on the word there, pronunciation, but simply by multiplying the number of rows by the number of columns, you get the total area. So in this case, the area is calculated by taking the 3 by the 5, that's our rows times the columns, to get 15 square inches. And we abbreviate square inches by SQIN, or you could abbreviate it IN squared, either one, okay? And sometimes we think of it as inches squared because we're multiplying 3 inches times 5 inches, and if you tack on the units there, inch times inch is an inch squared. You could think of it that way, kind of a dimensional analysis way of looking at it, okay? Okay, so either way you want to think about that. And of course that applies whether you're looking at inches or feet or meters or kilometers or miles or whatever they are, okay? Okay, well that gives you an idea of how we define area. How do we define volume? Well, volume is not that much different, but instead of having little square tiles, you have cubes with equal size, okay, or equal sides, sorry. So with volume, you would look at, maybe some sort of rectangular solid, kind of like a cereal box or something, right? And then however many, maybe you have like, if this is 3 inches here, and this is 1 inch, and this is 4 inches or something like that, or maybe I'll make this 2, just so I have something to split up. And then, you split up here 3, 1, there's 2, so you have some piles of little boxes, and here you have 2 more piles going deep, and 4 stacks or 4 layers, okay? Well, those layers come all the way across. Oops, I should probably draw that a little bit lower, there we go. So the layers come all the way across, and you end up with basically each of the 4 layers will contain 3 by 2 blocks or cubes, 6 cubes, right? So you get 3 by 2 on a layer, that's 6, stack them 4 high, that's 24 little 1 by 1 by 1 cubes, okay? So each of these little cubes right here. That is if I can draw it kind of nice, that's not too bad. That little cube is a 1 by 1 by 1, right? Every dimension is 1 unit in length, and so that's what we call 1 cubic inch, or 1 CUIN to abbreviate. Sometimes they abbreviate it that way. Or you could do inch cubed, inch to the third power, right? 1 IN to the third. That's our unit of measure for volume. Now, of course, it doesn't have to be inches. It could be cubic feet or cubic meters, those sorts of things, cubic yards. And so, but what you're looking at is a cube, a 1 by 1 by 1 box that has 1 unit in length, whatever that unit is. There would be 3 of them contained, and it'll give you that cubic shape. Okay, so that's our unit for volume, and the square unit is our unit for area. Okay, so now what we'll do is we'll kind of look at in the next video how to compare, how to convert from one unit like cubic inches to another unit like cubic feet, or cubic feet to cubic yards, and so forth. And then we'll throw in some other random units like acres, and how they compare to square miles, that sort of thing. So stay tuned. We'll have a few conversions coming up next.